Good day, viewers, and thank you for tuning in to a new episode of Prokon Know-How. My name is Jacobus Oberholster. I'm an AEC technical consultant for Micrographics, and I'll be running you through today's episode. So the topic for today is monolithic beams and just the ease with which they are added to a SUMO model. As you can see, I've got quite a simple model set up here, and this is more so just to compare the results from adding a monolithic beam versus adding a standard beam to this model. I've got my slab, my 6 concrete columns, and my pad footings. My slab is also concrete, just for clarity. And I've added a 10 kilonewton per square meter load on the slab, and the self weight is also included in the load case. So if you click on the monolithic beam, you'll see the property palette gets populated here with all the parameters for monolithic beam. There's your section width, your section depth, and then the offset. And that offset value is very important. So with only end snapping on, I'm going to snap to the top of that column. I'm going to snap to the top of that column. And there is my monolithic beam. But there's a bit of a problem. What you'll see here, you'll see a little bit of red sticking out at the top of this column. So what I'm going to do, I'm just going to switch off my columns visibility. And you'll see that actually that monolithic beam is partially inside of the slab. And that is not an accurate representation of reality, which means that you'll actually have a localized thickening, if we can call it that, of material right there, and it will result in some, or rather result in less accurate analysis results. So this is all controlled by the offset, and to change that or to put in the correct offset, it is the section depth, which is 500 mils, plus the slab thickness, which is 250, so that's 750 divided by 2, and that is 375. And there we go. No gap. That is properly modeled now. Okay, so I'm going to put my columns back on. I'm going to run the analysis. Go to the results tab. And what you'll see here, which can also be viewed in the discretized view, which I'll go back to now, you'll see there's an analytical line, and there you've got your rigid links. So that, in essence, can be seen as the lever arm. So what we need to take note of is just the nodal elemental displacement on the side here. Well, they're just the element displacement, rather elemental. That just sounds weird. We've got our nodal displacement, we've got our element displacement. And what I'm going to do now is I'm going to switch to a new drawing where we'll try to model a standard beam in the same way. We will be able to do that, but just the workaround you'll notice that the workaround is actually quite lengthy versus just making use of a simple monolithic beam command that's already been built into the program for you. So again, just in the standard workspace, go to the discretized view, you'll see that analytical line there, and you'll see the rigid links that connected to the slab above. Right, so I'm going to open up the other drawing. So this is the standard beam model. And so what we need to do is to get an accurate representation, or rather an accurate copy of the monolithic beam from the other model. We'll need to add a 250 by 500 section, because that was the width and depth of the monolithic beam. So we click on beam, we make sure that that is the beam that is selected in the properties palette. With end snapping on, we connect that end and to that end. And already you can see there's a little bit of a problem here. So that beam is, the center line is lying right on top of that slab. I'm just going to change the section color for clarity. So what we need to do now is change the offset. Okay, so go down here, and the offset needs to be the same as the offset for the monolithic beam. So we'll do minus 0.375. And there we go. That's been offset now. So let's go to analysis. It'll ask us to mesh. Say yes. And what was quite interesting is to note that the results are actually identical, I think, except for the maximum y, which is minus 1.78 in the other model. But there you'll see your analytical line, and you'll see your rigid links there as well. And the finer the mesh or the coarser the mesh is of the slab, the more rigid links will be added, or the less of them there will be. So the coarser the mesh, the less rigid links there will be, the finer the mesh, more rigid links will be added. Okay, but as you can see, it's not super difficult, but it is a bit of a workaround versus just making use of the monolithic beam command already built into the program. All right, so I hope that helped you a little bit. I hope that showed you how to add monolithic beams. It's quite simple actually. And to remember that that offset is equal to the section depth plus the slab depth divided by 2. Thank you so much for tuning in. I'll maybe check you around on some of the other clips. And yeah, please leave a comment if you want me to model anything else or to show you how to model anything else. And I'll be sure to get to that as soon as I can.